Hello viewers. Well, I thought I'd give you guys a behind the scenes tour of my fountain setup here. I'm currently in my shop at the moment and working on everything. Anyways, this is one of my newest creations here. Trying to make an oarsman here where I can make the nozzle tilt back and forth, and that's like the servo right there, and I'm just using that piece of pipe to mount it in, and there's a small linkage, and it just, tilts it back and forth. There's the pump. That part down there swivels so the thing can move back and forth. The pump moves along with it as well. But I thought I'd show you what I was doing for last year's show, just for those who were curious about what I used. This is the basic fountain nozzle configuration here. For the base, I'm using just a concrete cobblestone base. It's screwed in. The base of the pump is screwed in with 4 aluminum screws. And then, of course, the pump snaps onto the top. And then I have a piece like this with some poly pipe, threaded hole. It's 90 degree, 3/4 inch, and then it's an 18-inch piece of 3/4 inch threaded PVC pipe, gender bender, and then the nozzle is nothing more than just a hose adapter here. I'll just pop that off. 3/4 inch to about a 1/2 inch poly hose adapter. Makes a great nozzle. The LED lighting. What I'm using here, I have a hose clamp to clamp the arms on. This is a candelabra configuration. I find it better when the lights are actually out further than they are, close to the base, like some of those ring type lights. I find these work better. The LEDs here, so I can get the camera to focus on this. They're 10mm LEDs. They're 1 watt. Ordered from China, and I'm using for the candelabra support here, the arms here is done with 10 gauge house electrical wiring, solid copper core. It also doubles as a heat sink as well. These LEDs have a wide spaded blade on them, and I solder the 10 gauge wire to these to keep it from overheating, and it's also the support as well. And then I put 10mm heat shrink tubing on there to block out all the stray light, and also to make this area waterproof. I take a syringe and I inject silicone grease in there as a displacing agent to keep water from getting in there, because this runs on DC current, and if there's any water that bridges between the two electrodes, electrolysis will occur and rapidly corrode the wires. So very important to make sure that's sealed up. And even though I shrink the tubing down here at the bottom, I don't shrink it here on the top, because I like to have something here to keep stray light from going everywhere. It kind of acts like barn doors on a Fresnel light, like if you work in theater. And I'm going to show you the pump here. It's just a cheap $20 Harbor Freight pump. It's the 1,000 gallon per hour, runs on 12 volts, just a little bilge pump. Nothing really fancy there. Another thing I'll show you is, I don't know if the camera can pick this up, but this is one of the pipes that comes up out of the water. When the setup is running, when it's in the kiddie pool that I showed earlier, this is the water line right here. This part's above water, this part is all underwater. And of course here we get freezing weather, and whenever the pool freezes over, there's usually an ice slug that forms in the neck here, and with the candle wax coating on the inside of the pipe, if I turn the pump on, the pressure of the pump will force the slug into this area here, and then the water will just kind of run around it and dissolve it down, and then whatever small pill or whatever just pops out the top, and then I get normal spray gain. It's an automatic means of clearing. I don't use any chemicals, and I don't heat the water at all. I basically just exploit the physics of water to help the system survive freezing weather. For those that are curious, there are no valves. All the control is done entirely by controlling the power to the pump. And I'll come over here and I'll show you the control setup I have here. These are all the connections that go to the pumps. These are the pump drivers. These are power MOSFETs. And I got some chips on the bottom as well. It also not only uses power MOSFETs and pulse width modulation to control the power, but it also monitors the current of each individual pump. And that information is then fed back to this chip here. I don't know if the camera will focus on it. This chip's known as an FPGA. It's Altera Cyclone 2. It's just a cheap little $20 dev board you can pick up from China. It just comes right out of Hong Kong. And this is the LED drivers, all the resistors, and then I'm just using some ULN 2003 drivers to control the power with, and then these are just the individual Cat5 plugs that go to all those LED lights, the candelabras on each of the nozzles. Okay, this is the main power supply here. Supplies 5 and 12 volts. That powers the Arduino, the FPGA, the MOSFET drivers, and powers all 45 of the LED lights out on the nozzles. And then over here, get that out of the way. These are the 4 pump power supplies. I have 15 pumps. So each one of these runs 4 pumps. One of them only runs 3. They're 360 watt. They're 12 volts at 30 amps each. And then I have some capacitor banks off this side here connected. Bunch of small caps tied together, totaling around 50,000 microfarads. I like doing this configuration instead of one big cap because it really drops the ESR. The ESR level is really low, and it also just makes a little more conformable shape there. And if we come over here, I have an Arduino. The Arduino is going to run the servos. It also decodes the DMX 512 signal that comes in, and it also talks to the FPGA. There's a SPI bus over in the corner here, and I just send SPI data over here to the FPGA, which then controls the lights and controls the pumps. One of the reasons why I'm using an FPGA is actually for several reasons. I get more channels here. I got a total like 60 channels here. I get 15 channels for the pump and 45 channels for the LED lighting. That's 15 times 3 because it's RGB. And I just got some control logic in here where I can time the pump control with the timing the LED, because I perform a lot of persistence of vision effects. If you watch in my previous video that I released, there was a persistence of vision effect, like with a rainbow tree. There was a candy cane effect. It's hard to pick it up on camera. It looks much better in real life. But anyways, getting back to the Arduino here, it's this board here is an Arduino Mega 2560. Handles the DMX, talks to the FPGA, and it also drives the servos with, well, this year I'm going to add Oarsman there. That's actually my Oarsman setup. I'll start that up and show it to you later. But I'm driving all the servos out with this, and I also use the analog input on here for an anerometer sensor. I'll get to that in a moment. And I'm also connecting a couple of motion sensors, which I put out by the street. So if nobody's around to watch the show, it just simply puts it to sleep, turns the water down, just kind of let it percolate and keep it from freezing. But anytime the water's shooting up in the air, it wastes water. So I like to be able to, when nobody's watching the show, just kind of tone it down so I'm not wasting water or wasting electricity. I turn off my lights and everything. Anyway, so I'll show you this over here. This is the aeronometer sensor. If you don't know what that is, it's actually a wind speed detector. The reason why I use this on my fountain is if you've ever watched the fountains at Bellagio, you probably have seen shows canceled because of wind. Well, I'm no exception here. I got to watch the wind too, and one of the problems we get is we get these, sudden wind gusts. It can be completely calm, and then all of a sudden, just for a few seconds, we can get like a 20-mile-an-hour wind gust blowing through, and it wreaks havoc with the fountains. It just blows all the water out, and I lose that water, and it's just wasted water. So one of the things to do to solve this problem is I built this aeronometer sensor. And get a better view of it here. It mounts in like this. This is its upright position. The top here is just to keep rain off of it, and I try to keep the supports as far away from the actual sensor right there. That's the actual sensor. What that is just your standard. Let's see if I can go down here a little bit and get a better focus on it. That's just a standard 1N4148 diode. There's actually two of those. So there's that one there, and then there's one inside the pipe. The reason for that is you have one that's called the exposed diode. That one you're seeing there is called exposed, and then the one inside is called the protected diode. Anyways, the way this thing works is it works by taking advantage of the wind chill factor. The protected diode basically just sets itself to ambient temperature, whereas this one, if the wind or anything blows on it, the wind chill factor will actually cause it to cool down faster. And I take the two outputs of these voltage drop. If you know anything about diodes, especially silicon diodes, there's about a 0.6 volt drop across these. And what I do is I measure the difference. Basically, how this works is I run a low resistance resistor in series with this, and I basically over bias these diodes. I actually stress them to the point where they get hot. I actually push about 250 to 300 milliamps of current through these things, so they actually get warm. And then I hook up an op amp and I measure the differential between the two diodes. And the reason for this is at ambient temperature they both cancel each other out, so you don't get an ambient temperature reading. But if the wind suddenly blows, because this one diode is exposed, the wind blowing on it will help it dissipate heat quicker, and it creates a voltage differential between the two diodes, and that's what I detect. And then I take the analog signal from the output of the op amp and run it into the Arduino. What else did I say? This thing is not exactly very accurate, and the reason why I chose this method over like one of those normal aeronometers, the little pinwheel thing with the cups on it, those are extremely accurate, and of course they're used in weather stations. The problem with one of those is they're slow in response. If a wind gust all of a sudden came in, it would take about 2 seconds for that signal to finally get to the Arduino. This thing has an instant response. I mean, I think the delay on this thing is only about 150 milliseconds. But anyways, I go ahead and show you that. My little wind speed sensor. Very important accessory to anybody who has a fountain for a show. Okay, let's go ahead and talk about the control here. I use DMX 512 theatrical lighting protocol. What I'm using here right now, I just have this in bypass mode. I'm just going TTL logic signal right off the chip. But normally, when I have this show deployed, I'm going to run an RS-45 from this green plug, over to another RS-45 receiver. But right now, because I'm just testing it right now, I'm just running it directly. This little board here is just a little cheap, made in China. These things sell for about $6 on eBay. The thing about these particular USB to RS-45 converters is this one has the FTDI chip on it. It's important. I don't know if most of you know this or not, but if you happen to have a device with an FTDI USB to serial converter on it, you can actually get the NTEC Open DMX driver and actually turn these things into a DMX dongle, and that's exactly what I've done here. anyway, it's just a long USB cable running back, and so I'll wake up the computer here, and I don't know if I got the programs loaded or not, but I'll show something here. I get the camera to adjust. This is what I use for control software. It's called Q-Light. It's a free open source, very light program. It only uses about like 6 megabytes on the install. And I also use inter-MIDI communication. I use this piece of virtual MIDI software called MIDI-Aux. There's another driver that's called the MIDI yoke. They just kind of work in complementary. This is just MIDI monitoring. Or you can also do translations, like you can change notes or change velocity and do patching work. Nice little utility to have if you're into MIDI. And then on the second monitor here, this is what I use to actually sync it up with the music. I just use a soundtrack. When I play the soundtrack, then I use MIDI events to trigger it. Right now I don't have my MIDI keyboard in here, but I'll plug in I got like a MIDI keyboard, and I can, and also have a MIDI knob box controller, and I can just record multiple tracks. I can work, different effects when I program the show, and sometimes I can set up a few macros and do a real-time show. But like I said, it's all, I use mostly professional lighting. There's no reason why this couldn't be done with like Vixen or Light-o-rama, but I'm not a particular fan of those, mainly because I work in professional lighting, and I like to use professional software and Light-o-rama and Vixen, or just more for amateurs. Not I'm saying that they're bad or anything, but like I said, I'm into professional lighting. I like to use the pro stuff. It's more powerful, a lot more powerful. Well, anyways, I thought I'd just show you the what I'm working here. Okay, this is what it looks like when it's running. You can see the servo running in there, but just rocks it back and forth. And I'm just showing you up close here. I don't have any water on here. Give me a second, I'll turn the water on for you. Okay, that's what it looks like with the water turned on. Now my hope is that these won't freeze, because one of the things I'm going to have to do is I'm going to have to make sure that when that water comes down, it blasts it pulverizes a larger hole in the ice so that the water can, well, the idea is I'm trying to use the force of the water to dissolve the ice and dissolve a big enough hole there so that the mechanism doesn't get jammed. So like I said, this is my first time trying this year, so we'll see what happens if this can handle up to the ice. Okay, this is what it looks like with its LED lighting on. Now normally I'm going to have a couple of static nozzles on each side with lights, and as this thing tilts, I'm going to use the light from the adjacent nozzles to illuminate the water. As you can see, I don't have it up very high, because if I put it up any higher, it'll just fall out of a beam of the light, whereas here, if I keep it low like this, it's all in the light. Anyways, I'll be working on some shows, and I'll post some videos up when I have more up here. So